What's up everyone? In this video we're going to be starting our unit 10, which is going to be on solids, and we're going to start just by talking about area and perimeter of 2D figures. So content refresher, remember that area is the total space inside that a 2D figure takes up. It's the region inside of your figure, and the units are always squared. So for example, we have inches squared, feet squared, centimeters squared, right? Whenever you see this squared at the top, that's usually a giveaway. That is an area measurement of 2 dimensions. So there are a bunch of different area formulas given to us on our reference sheet. So on our you don't have to remember these 4. You're given area of a circle, you're given area of a triangle, you're given area of a parallelogram, and you are given the area of a rectangle or a square. However, you're not given the area formula for a rhombus, so it really helps to commit this to memory because it's going to make it easier for you. The area of a rhombus is diagonal 1 times diagonal 2 divided by 2. Now, for more of our content refresher, we also have perimeter of our figures, and the perimeter is the total distance around a 2D figure. So you want to think about this as the border or as the outside of the figure. Now, for a polygon, we add up all of the sides to find our perimeter. So if you have a rectangle or a square, you add all of the sides up, and that's great. However, if you have a circle, circles don't have sides. So for circles, you have to remember that the perimeter is the same thing as the circumference. And again, we're given the formula for circumference, so you don't have to remember that. However, there might be some word problems that say, hey, I have a circular garden and I want to know the perimeter of it, right? You're going to have to be able to relate that in your brain, that perimeter is the same thing as the circumference of the circle. So we're going to be working a lot with composite shapes. So we're not just going to be finding area and perimeters of squares, right? We're going to be putting these together and working with these composite figures. So a composite figure is a shape composed of 2 or more geometric figures in one. So in this slide, we have a minor complex example of a composite figure. They can get a lot crazier. We can add a bunch of different shapes and make whatever composite figure we'd like, but to make finding the area and perimeter easier, we usually split up the figure into familiar shapes, and then we calculate the area or perimeter of those individual shapes, and then we add them all together. So skill number 1, let's go into finding the area and perimeter of composite shapes. So in the diagram below, we have a figure with a square with side of 4 centimeters, a semicircle, and an equilateral triangle, and we want to find the area and perimeter of this composite shape. So, and we're rounding to the nearest tenth. So again, we always want to break these figures up into familiar shapes, so it's nice enough to tell us what we have. So we have a square for our first shape, we have a semicircle for our second shape, and remember, semicircle just means half of a circle, and then for our third shape we have an equilateral triangle. And let's go ahead and get started. So for our square, it tells us that we have a side of 4 centimeters. Now you guys know that squares, all 4 sides are congruent, so I can go ahead and put 4 centimeters in over here. And I also know that for these dashed lines, they're also going to be 4 centimeters, and that's going to help us a little bit later on. So to find the area of a square, we know we just do length times width, or base times height, right? That's going to give us 4 times 4. So we are going to get that the area of that square is 16 centimeters squared. Okay? So now what we have so far is the shaded region just inside of the square right here. Now we're going to do the area of a semicircle. So remember, area of a circle that's given to us is pi times r squared. So the area, we have pi. Now our diameter here is 4 centimeters, which means that our radius is 2. So it's pi times 2 squared, which is going to give us 4 pi centimeters squared. And then for our equilateral triangle, so again, we have this bottom side as 4, so we know that this is going to be 4 centimeters and this is going to be 4 centimeters. Now, usually for area of a triangle, we need the base and the height, so it's base times height over 2. Now, the height isn't given to us, it should be, so let's just go ahead and add in that height. Let's add it in as 2 centimeters for now. So our area is going to be our base, which is 4, times our height, which is 2, divided by 2. And when we simplify that, we get 4 centimeters squared. Okay, now for our semicircle, we forgot to talk about this. This would be the area of a full circle with a radius of 2. But we don't have a full circle with a radius of 2. We have half of it, right? So what we need to do is divide this by 2. So we're going to do 4 pi centimeters squared divided by 2, which is going to give us 2 pi centimeters squared. I almost missed that one. So be careful, there might be times where you have a quarter of a circle or a half of a circle or a full circle. Just be mindful when you do your full area, this is for the full circle, and then you got to divide it by 2 or divide it by 4 to get your semicircle or your quarter circle. So for total area, we're just going to add all of these up. So we get 16 plus 2 pi plus 4. And since it's telling us to round to the nearest tenth, we can go ahead and just plug all of this into our calculator. All of it in, 16 plus 2 times pi plus 4, and that gives us 26.3. And that's going to be centimeters squared. So the total area of the entire composite figure is 26.3 centimeters squared. Now the next part that we're going to deal with is finding the perimeter, and remember, perimeter is just the outside, so you want to be really mindful here. We'll do the perimeter stuff in blue, but the perimeter is only the outer edges of the figure. So if you notice, we have these dashed lines. These dashed lines are not included in our perimeter, so you have to be really, really, really careful here. Some people forget that and add up all the sides anyway. But when we're dealing with the perimeter of our square, right, we're not dealing with all 4 sides here. So it's technically not even really the perimeter of the square, but like we're only adding up the 4 and the 4, like from here and from here of our square, okay? So far we have 8 centimeters for that. But when we're finding the perimeter of our semicircle, we know that perimeter for circles is the same thing as the circumference. So we know that the circumference of the whole circle would be pi d, but we don't have, we do have the diameter. So the circumference of the whole circle is 4 pi centimeters, but we don't have the whole circle. We only have half of the circle. So the circumference is going to be 2 pi for this portion, right? So I'm going to go ahead and fill in 2 pi in just for this region over here. 2 pi centimeters. And then for our equilateral triangle, again, we only have these 2 sides that we're accounting for here. So that's just going to be, again, 4 plus 4, and that's going to give us 8. So when we add all this together, we get 8 plus 2 pi plus 8. So we have 8 plus 2 times pi plus 8, and that gives us 22.3. centimeter. These are just some other examples of compound shapes that we might see. Again, just make sure you're breaking up those figures into familiar shapes that you see. Make sure you are not accounting when you're doing the perimeter, that you're not accounting for these sides here and these sides over here, right? You only can account for sides that are on the outside of our figure, and then you guys will be good to go. Now, skill number 2 is, again, working with area, but it's when we have 2 shapes inside of one another, and it's going to be asking us to find the area of shaded region. So when we're finding the area of a shaded region, we're always going to do, or 99% of the time, we're going to do the area of the outer shape, and then we're going to subtract the area of the inner shape. So in this example here, we have rectangle AFEB and semicircle with diameter CD. It says that AB is 5 inches, and then it says that AB is congruent to BC, is congruent to DE, is congruent to FE, and it tells us that CD is 6 inches. And it wants the area of the shaded region to the nearest hundredth. So let's go ahead and fill in some other measurements. So I can fill this in as 5 inches, this in as 5 inches, this in as 5 inches, because they were all congruent, right? And we have a rectangle, so that means that this entire side here is going to be equal to this side that's up here. So we do 5 plus 6 plus 5, and that gives us 16 inches. So again, we're doing area of outer shape and then the area of the inner shape, and we're going to subtract them. So the outer shape is a rectangle, so the area of our rectangle is just going to be length times width. So the area is going to be 16 times 5, and if we do that in our calculator, we get 80. So the area of our rectangle is 80 inches squared. And then the area of our inner shape, so the outer shape is a rectangle, the inner shape is a half circle. So the formula for the area of a circle is pi times r squared. So we have pi. Now we're given our diameter here, so we need to make sure we half that to get our radius. So pi times 3 squared. So the area of our entire circle would be 9 pi, but we don't have an entire circle, we have a half circle, so we need to divide this by 2. And when we do that, the area of our semicircle is going to be 4.5 pi inches squared. So what we need to do to find the shaded region is we subtract. So we have to do the area of our rectangle minus the area of our semicircle, and that is going to be 80 minus 4.5 pi. And again, we're rounding to the nearest hundredth, so we can go ahead and put this right into our calculator. We do 80 minus 4.5 pi, and that gives us 65.86. And that's going to be inches squared. Now the last skill is using Heron's formula, so it's just an equation to remember to find the area of non-right triangles. So Heron's formula is listed for us over here. Now this is not going to be given to us on our reference sheet, and it is a bit confusing. You just have to remember it. So the area is equal to the square root of s times s minus a times s minus b times s minus c. Now a, b, and c, these are just sides of our triangle. So a, b, and c, it doesn't matter what you put as a, b, or c, those are just your three sides. And then s is your semi-perimeter. Now another word for semi-perimeter is just half of your perimeter. So let's just get right into an example. Again, it helps when we list out our variables so we can see what's going on. So in the accompanying diagram, we have a triangular plot of land located in Moira's garden, and we're going to find the area of the plot, and we're going to round to the nearest hundredth. Okay, so again, S is our semi-perimeter, so we need S, A, B, and C, and then we plug everything into that formula to help us find the area. Now again, like, we have a triangle here, and if we had the height of the triangle, we'd be good to go in using our formula that's on our reference sheet, but we don't have the height right now, so we have to use Heron's formula. So I'm going to just label. I'm going to pick, it doesn't matter what we pick to be A, B, or C, but I'm going to pick this to be A, this to be B, and this to be C. So A is 160, B is 135, and then C is 125. So our semi-perimeter is half of our perimeter. So I'm going to do, in my calculator, 160 plus 135 plus 125. And what that would represent is the entire perimeter of our triangle. And we're going to divide that by 2 to find our semi-perimeter. So our semi-perimeter is 210. And now we have all of our variables. Let's just plug it in. So A is going to be equal to the square root of 210 times S minus A. So times 210 minus 160. And then we have times S minus B. So times 210 minus our B value, which is 135, times 210 minus our C value, which is 125. So again, we're just plugging and playing into our equation here. And from here, you can just plug this right into your calculator. Yeah. So area equals 8181, and we're rounding to the nearest hundredth, so 0.53. And that's going to be, does it give us units here? I forget our units. I think it's feet squared. Yep, okay. So again, with Heron's formula, you just have to remember the formula and just figure out what your S is, which is your half perimeter, figure out A, B, and C, and then you are going to substitute, plug it right into your calculator, and then you're good to go. So here's our Edpuzzle recap. So skill 1, we're cutting up complex diagrams or compound figures, right, into familiar shapes to find the area and perimeter. Be mindful of the sides that are not on the outside, right, when you're finding your perimeter, and be mindful of the words semi and quarter when you're dealing with your circles. The second skill was finding the area of shaded and unshaded regions, where we're taking the larger area and then subtracting the shape of the inner area, or the area of the inner shape. And then skill 3 was using Heron's formula to find the area of non-right triangles. Our calculator, we're going to just type everything in. So we have the square root of 210, and then we are multiplying in parentheses, right? 210 minus 160, we're closing those parentheses, and then we have parentheses again with 210 minus 135, and then we have another set of parentheses with 210 minus 125. We're closing that parentheses and we're hitting enter, and there's our area.